I have a conflict at 10 o'clock, so I'm going to stop class at 9:55 so I can make it back to my office because I forgot my cell phone today, which is really, really bad.
I can run real fast.
No, I left it at home.
Yeah, I can't run that.
I was on my way out. I left it at home, so I can't even take the cell phone over here. I have to get back to my office. No, I'm working with a very dear friend of mine. His name is H.N. Chang. He will be the chair or the president of the American Chemical Society next year. And we are working on his presidential year. So he has a committee together, and I'm on his committee. So I've got to work with this. So this is actually problem 361. Okay, and I am not going to set up, but you have three force vectors that are coming in, and we're told that this vector at the top is 800 newtons. And it's problem 361, so you guys can go in and look at the picture. But what I want to do is this. We get to the summation of forces in the x direction, the summation of forces in the y direction, and the summation of forces in the z direction. And this is going to equal, so this is the x1, it's 0. And you guys can work through it, but I went ahead and put it into the decimal format. So this is 0.3 or 53 FAB plus a minus 0.324. I'm going to change this up. So you've got the idea of where we're going. I'm going to give myself more room. 0.53 FAB minus 0.324 FAC minus 0.492 FAD is equal to 0. So I get 0.53 FAB plus 0.487 FAC minus 0.615 FAD is equal to 0. And I get minus 0.662 FAB minus 0.811 FAC minus 0.615 FAD is equal to negative 800. So those come from my summation of my forces in the x direction, summation of my forces in the y direction, summation of my forces in the z direction, and just as a reminder, this is problem 361. So we get to this point, and we have to solve for FAB, FAC, and FAD. So I talked to you guys about the determinant method on, today's Wednesday, right? So I talked to you guys about the determinant method on Monday. So if I do the determinant method, basically what I'm doing is that the determinant, if I do it, it's going to be A1, B1, C1, A2, B2, C2, A3, B2, C3. And if I do this, I can come up with a number that's A1, and then I do the B2, C2, B3, C3, and then I got to do the minus thing, and I do A2, B1, C1, B3, C3, and then I do the plus, and then I get A3, and this is B1, C1, B2, C2. And this equals A times B2, C3 minus C2, B3 minus A B1, C1 minus C1, B3 plus A, this is A1, that's A2, this is A3, and this is B1, C2 minus B2, C1. Okay? And that'll give you a number. So if I do this D, and I plug this in, and I get this, and I get 0.53 minus 0.324 minus 0.492. 0.53 plus 0.487 minus 0.615, and I get minus 0.662 minus 0.811 minus 0.615. Do all of that lovely. That number works out to be minus 0.60774. All right. I do that because to solve for FAB, FAB is going to be the determinant 0, 0, minus 800 minus 0.324, 0.487 minus 0.811 minus 0.492 minus 0.615 minus 0.615 divided by that major determinant that I just calculated. If I do this, that top number becomes, for FAB, that becomes minus 351.091 divided by my 0.60774 gives me FAB is 577.7 or 578, and that's in newtons. So the determinant method allows me to solve multiple equations with multiple unknowns. This is Kramer's rule, doing the determinant. It's in your algebra book. It's one way to do it. So it makes it a little quicker than going through the gory algebra, right? Because I can manhandle and go through the gory algebra, 3 equations, 3 unknowns. Totally manhandle it. Grind, 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 grind. Or I can do it that way. Now, Corbin came to me with a question yesterday. And I went, oh, I remember that. And yeah, it's a shortcut method. So this is a real shortcut method, right? And if I want to do FAC, what I do is I replace the middle column. And if I want to do FAD, I replace the other column with the answer column. So if I'm doing FAC, what that one looks like is 0.53, 0.53 minus 0.66200 minus 800. With the negative 0.492 minus 0.615 minus 0.615.
Can you pull it up?
In just a second. That's how I would do that one. And you just replace that one for the other one. So this is using Kramer's rule, using the matrix method. All right, starting with the same place. Okay, divide this first equation by 0.53. This gives me FAB minus, and if I do that, this gives me 61132 FAC minus 0.9283 FAD is equal to 0. So this is a divide by 0.53. Solve for FAB. Okay? I'm going to divide this one by 0.53 as well. That number becomes 0.918868 FAC minus 1.16038 FAD is equal to 0. So this is this one divided by 0.53. Plug that into there. So I got 0.61132 FAC. I'm adding it to the 0.198868, and that gives me 1.530189 FAC. 0.92283 plus that one gives me a negative 0.238208 FAD equals 0. I'm going to divide this by this 153 thing. Gives me FAC is equal to 0.238208 FAD. Now,
Wouldn't that be divided by our 1.53?
yeah, that's, yeah, wait a second, I just didn't write down the number. Hang on, let me write it down. That ends up being minus 0.15166. That's what it ends up being if I do the divided.
Should it be positive because we added it to the other side?
Yep. I'll show you my notes here in a second and blow it all up so that you can see how I did it. All right, got that? Okay, I'm going to plug that back in to my third equation with the 800. What I do for that one, and I can find that FAD is equal to 566 newtons. Plug it back in, and you get the exact same answers the other way. This is called the Gauss elimination technique. So if you look it up, that's the technique that's being used to solve it. So when you get 3 equations, 3 unknowns, this can be used for multiple ones as well. Most of the time, that's what we're going to end up with, 3 equations, 3 unknowns. We can get as many as 6 equations, 6 unknowns, because we can have summation of the torques. We'll have it in X, Y, and Z direction for torque, or moments in the X, Y, and Z direction. And we're going to have the forces in the X, Y, and Z direction. So either of these mathematical techniques is going to get you there. So let me show you gory detail here. I went ahead and did this in Excel just so I could keep track. So there are my determinants. These are my matrix determinants where I plugged in, so scroll in here completely. There's as good as I can get. So I did it in Excel just to make it easier to keep track of things. So here's the main determinant, which gives me my denominator. Here's the solution for FAB, which gives me, that's my determinant divided by that one gives me that one. This one divided by that one gives me that one. This one divided by that one gives me that one. There are my three equations that we started with. This case I divide by 0.53 by 0.53 to come up with this right here. And it's minus 0.622. Gives me clean equations to play with right there. I'm going to use this first equation to replace in the lower two equations. Go ahead and sum them up. Then I'm going to divide by the 0.530 and divide by the 0.180 to give me these two equations. Use this one to replace in that one. Gives me that, which gives me my FAD solution, my FAC solution, and my FAB solution.
So the matrices is probably easier?
It just depends. I mean, this one might be easier if I'm only trying to, either one of them might be easier depending on what I've got. It just depends on which one's going to be easier. This is called Gaussian elimination, and that's a determinant method. Now, this one is going to be much easier when my matrices get to 4x4s or 5x5s. From 6 equations, 6 unknowns. This is going to be easier to deal with.
Yeah, that'd be a nightmare to try and use that Gauss elimination.
Right. But for 3 equations, 3 unknowns, this one might be the easiest way to do it. Might be able to give you that, gives you a couple of different ways other than just grinding through the frickin' algebra. And guys, I'm telling you, once you set up an Excel spreadsheet for solving determinants, simplifies life tremendously. And some of you have a calculator that will solve matrices, right? If you've got a calculator that will solve matrices, then you're golden.
I don't even know how I program Excel to do that.
Oh, this is easy. To program Excel is this right here. All right? This is remember that this right here, so if I put my matrix in here, these are 9 cells. This becomes this cell times parentheses, this one times this one minus that one times that one. That cell is the second one, okay? That cell is the second one. Same thing, you take here's A2, 0.53, except now it's that cell minus this, or that cell times this cell minus that cell times this cell. Do the third one. That's why I broke it out here, guys, so I could keep track of which ones that I had. Okay? I can keep track. Then this is just that cell minus that cell plus that cell. Gives you that value right there. And once I have that, then it's easy just to replace, copy, 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 and now you just replace whatever your other numbers are. So you can set up yourself an Excel spreadsheet that will do that determinant. And I think, I just didn't look for it because I didn't have time and I wanted to be able to work through all of this yesterday. I didn't have time, but I think there's even a matrix solution function in Excel. I just didn't dig for it to find it because it's so easy to set this one up.
I know back in Visual Basic they had the thing.
Yeah, you can do it.
Yeah.
But this one, this one's so easy to set up. It was quicker to set it up than it was to try and find the stupid function. And then like I said, I did this in cells. So these cells are the numbered cells are the calculated cells, just so I could walk you guys through each individual step. And there are, like the Texas Instrument one, the graphing calculator, I'm pretty sure does matrices in there. I even think this sucker would do matrices. I just haven't, again, it takes more time to learn how to program it than for me to do it this way. I know my old HP calculator did matrices, and I remember doing those, so once you punch them in, it solves it for you. And that, I thought.